Okay, so for the short proof, I mean, this is gonna really need a a proof that is really short. I mean, we can just say a sentence, and this is really a consequence of invertible matrix theorem. So I can say this. I can say suppose A is invertible. A is invertible. So that will be namely. So this is equivalently saying that A inverse exists, right? So then by invertible matrix theorem, IMT, the columns of A are linearly independent, right? The columns of A though. So if A is this, like if A is A1, A2, N, then the columns which are this A1, AN, this is linearly independent. Linearly independent, right? Now, because A inverse exists, and if a matrix is invertible, its inverse is also invertible, right? That's also one of the consequences. So also we have this, right? Also we say A inverse is also linearly, A inverse is also invertible, right? In fact, the inverse of this will give you back A, right? So since A is invertible and the columns of A's are linearly independent, A inverse is also invertible. So therefore, by the same theorem, invertible matrix theorem, we'll say by invertible matrix theorem, the columns of A inverse, are linearly independent, So it's really just, consequence of invertible matrix theorem, together the fact that if a matrix is invertible, then its inverse is also invertible. So therefore, if the columns of A are linearly independent, by the same reason, the columns of A inverse are also linearly independent.